Hey, how's it going, everybody? My name is Nick Palavita. I'm the CEO and founder of Recyclers Exchange, and I have a new and improved pitch deck. So I thought I would share that with you guys today, since it's looking a lot better than it did last time. It's amazing what people on Fiverr can do. Um, so we have some introductory screens here. What we're looking to do is turn plastic waste into fuel, but I actually think we're going to modify that a little bit, and I'll explain that in just a second. But yeah, um, so our mission is to create a sustainable solution for plastic waste management by turning plastic waste into a commodity, and hopefully building the infrastructure for that. What we're trying to do is build the first ever solar thermal pyrolysis plant where we melt plastic with the power of the sun and turn it into pyrolysis oil. I do not believe that there are any plants such as the one we're suggesting here currently out there on the market. And also, the reason why we want to melt the plastic with sunlight or solar power is because if you can imagine melting plastic, that requires a lot of heat. It's about 500 degrees Celsius. Um, so, in order to forego the carbon emissions that would be caused by melting it conventionally with electricity, which would contribute to carbon emissions, because a lot of electricity is generated through fossil fuels and they emit CO2. We're trying not to trade one bad for another. Like we're helping clean up the oceans and get plastic out of the oceans, but then we're contributing to climate change. We're trying to stay away from that. So that's why we're looking at solar thermal pyrolysis plants. So in case you're not aware, plastic waste is a major problem. Um, I'm actually only doing this because I took the vow in the Bible, Numbers chapter 6, the vow of the Nazarite. And uh, that's also why my hair is like this. It's all grown out. That's part of the vow as well. But a lot of the prohibitions in the vow drew my attention to our plastic waste problem. And I am under the impression that it is a long term um, we're underestimating the long term severity of our plastic pollution problem on this planet. Is the impression that I get when I read Numbers chapter 6, and also when I look at it. 8 to 13 million metric tons of plastic waste end up in the ocean each year. 100 million marine animals die each year from plastic waste alone. Microplastics have been detected in fruits, vegetables, plastic water bottles, the air, cosmetics, and household dust. It's everywhere. And they're finding it in almost every part of the body. And traditional recycling methods have proven to be insufficient and economically unviable. So, what I'm trying to suggest and advocate for is that we change market incentives, and by changing market incentives, that will change consumer behavior, and hopefully we'll be able to mitigate the plastic waste problem. Right, like if plastic waste has a price attached to it, people generally don't throw away money. Like they don't dump money into the oceans. So what we're trying to do is build the infrastructure so that we can be a reliable buyer of plastic waste and commodify it and turn plastic waste into fuel and make it a useful thing and make it a more circular product. Um, yeah, so that's our solution. Is pyrolysis. Um, it's heating organic matter in an evacuated chamber. So you suck all the air out of the chamber, and that way the hydrocarbons don't react with oxygen and ignite. And you can heat the chamber up, and you melt the plastic, to its boiling point. You condense it, and you get pyrolysis oil on the other side. Um, I like to say that a lot that the first step is failure, right? Like, in order to get where we want it to be, we're probably gonna have to fail first. So I don't expect this first plant to be a failure. I expect it to be a success. But in order to initiate change and move towards a solution, I think we have to move this direction. Like we're trying to make plastic waste a commodity by turning it into fuel, and I believe that by going down this avenue, we'll be able to discover other solutions to our plastic waste problem. But first, we have to be able to convert plastic waste into fuel through pyrolysis. Um, and we have to build the infrastructure all across the nation and all across the world in order to make that happen. The benefits include a cleaner environment, reducing reliance on fossil fuels, and financial incentives for recycling. And I think that's the big key thing here is like when you have something of value and you can sell it reliably, that won't end up in the ocean. um, yeah, the market opportunity here is vast. Plastic is everywhere. It's used in almost everything. Um, the fuel market is stable, I would say. Like people are always going to need fuel in some capacity, and target customers include waste management companies, fuel distributors, and environmentally conscious consumers. Yeah. Also, to get back to a point that I was going to make earlier, is that by being able to turn the plastic waste into pyrolysis oil, we can then turn that pyrolysis oil back into plastic products. My business partner, master contractor, Chris Foley, he was like, you know what we could do is we could turn the pyrolysis oil into building blocks for housing or storage sheds. And that way the plastic acts as a carbon sink. Because right now, all this plastic pollution in the ocean, all that's terrible, is actually acting as a carbon sink because all those hydrocarbons are just like locked and stored in there. So if we turn it into fuel and use it as fuel, well, we're just contributing to global warming, right? Like, so we're like stuck between a rock and a hard place. Well, third way that is possibly a solution to the plastic being in the oceans and you don't want to contribute to global warming is to use the plastic waste that we gather in other products and other alternative products that act as a carbon sink in either construction materials, fiberglass, building blocks, and all those things can also be recycled in case at their end of life and repurposed and reused in our pyrolysis machines, and then they can be uh, taken to market again and turned into different things. So this is how we're different. Right now, pyrolysis is done through either electricity or hydrocarbon products. Pyrolysis oil. They tend to take the pyrolysis oil they make and then use it to heat their pyrolysis machine. Or they use gas or wood or coal. Um, but that all contributes to global warming. So in order to sidestep the carbon emissions problem, what we're currently doing is we are developing a heliostat system where we're using the advances in machine learning to make a simplified heliostat that we can sell to consumers and industrial partners, and that we can use to heat our pyrolysis machine, and that's actually the main reason why we're developing it, is because I was looking for to power our pyrolysis plant through photovoltaic, but I was looking at the square footage and I was just like, why don't I just like heat it directly with mirrors? And then I tried looking for off the shelf equipment for a heliostat farm, and I came to the conclusion that my best bet was if I developed a heliostat system on my own. So currently, I'm also working on that. I have a prototype on my roof, and I'm working with a machine learning developer to make a functional prototype for a demonstration. Um, but that's essentially how we're different and the direction that we're looking to move. A lot of environmental groups don't like the carbon emissions that come with melting plastic, if you can imagine, and they don't like the sulfur that's in the pyrolysis oil from melting the plastic. Sulfur is used as a bonding agent in a lot of plastic materials, and when you melt it and you get the pyrolysis oil and you refine it into gasoline or diesel, you still have sulfur in it, and then you're just making another problem by solving one problem. So to sidestep the carbon emissions and the sulfur issue, we're looking at heating our chamber with the power of the sun, and we're also looking at uh, turning the pyrolysis oil into something that acts as a carbon sink in the long run, such as building blocks or construction material, or reusing it as plastic, turning the pyrolysis oil back into plastic. So it acts as a carbon sink, and we're not contributing to a different problem. To couple the heliostats that we're developing, we're also looking at a thermal sand battery. Um, uh, so we're going to be operating our plant 24 hours a day, 7 days a week, and the sun's not on all the time. But during the day, there's downtime when you have to feed the machine to, um, you have to feed it with plastic and before you can melt it. So during that downtime, we're going to be setting up some thermal sand batteries that can store the heat during that downtime to be released later and used on our pyrolysis plant overnight, or if there's a cloudy day and there's no sun, we might have enough on hand for 24 hours or maybe 48 hours or something. Um, so thermal sand batteries are just like crazy efficient. Lithium ion gets about 90% efficiency. For every electron you put in, you get 0.9 electrons out. You put 10 electrons in, you get 9 out. It's pretty good. With a thermal sand battery, sand has a 94% round trip efficiency. So you put in 100 units of light or heat into the thermal sand battery, and you get 94 units of heat out. And it's way cheaper than lithium ion. And you don't have all these rare earth metals, nickel, cobalt, all these gross things. You just have sand, and sand is generally pretty inert. So it's way more environmentally friendly, and it's less expensive than lithium ion. And ChatGPT was saying that we need uh, 10 cubic meters, 100 cubic meters. We'd probably just build one that's the size of 2 tennis courts, just so that we have plenty of sand on hand. But yeah, that's how we're looking to be different, and how we kind of want to change the pyrolysis market is we want to move the pyrolysis market to using renewable energy, and the excess energy that we generate, we'll throw in a thermal sand battery and we'll draw from it at night or on a cloudy day. So this is just a quick funding breakdown of what we're looking at for funding our plant. We're looking to raise about $2.5 million. Our two biggest expenses are the pyrolysis plant, which is about $1 million, and land acquisition, which is about $500,000. Everything else is pretty inexpensive. The heliostat system that we're looking to put together, it's two motors on a square meter hooked up to a mirror with some DC motor controllers. So I have great faith that we can do it for about $100,000. And the thermal sand battery sand is really inexpensive. And my guess is we can do that for about $100,000 as well. And the reason why we can do the sand battery kind of inexpensively is because we're going to be using nitrogen as a heat transfer medium. It's not corrosive. It's inert. It's an inert gas. It's simpler. It's less expensive. It's less expensive to implement and handle than what a lot of solar concentrated power plants are using, or concentrated solar power plants are using. They're using molten salts or liquid metal, which is corrosive. It's gross. It's an environmental hazard. It requires special training to use, and I'm just like, we're gonna use liquid nitrogen. It's way simpler. Okay, so here are the financial projections, and I got this from Hoen Group, our pyrolysis plant supplier. They estimate about 3.4 million annually in revenue, about 1.7 million in operating expenses, and 1.7 in gross profit. And their estimated payback period is about 2 years. For those that are worried about the financial side of this, while we're looking to become a plastic waste buyer, initially it's probably going to just come to us for free because there's no demand for plastic waste in general. Our plant can also be used for tires as well. You can melt tires and recover pyrolysis oil, carbon blacks, the steel in the tires. So that is also another available feedstock for our plant. And yeah, there's lots of options available for feedstock to make sure that our plant is always running from day one. And this is our team. There's me. I'm Nick. Hi. And then my dad. He's our chief counsel, our executive vice president, and he is also going to be acting as our chief financial officer. He's a pension attorney by trade, so he is planning people's retirements. Like that's what he does for a living. Is he looks at money and how much money goes in and how much money you need to save before you retire. And then Dr. Shaman Poker, Shambu Poker, he is the chairman of the board. He also is the, I believe, World Trade Forum president, and that's an alternative organization that's going up against the World Trade Organization. It's something that he's trying to get East Asian countries to do and get on board with as opposition to the WTO. Chris Fili, he's our chief contractor, vice president, installation and housing. He has LEED credits in environmental and sustainable development. He also is he also builds houses, sustainable building houses. Smit Ramani, he's the product designer of the heliostat that we're working on. The prototype's on my roof right now. He's the one that designed it, and That's Zanuck. That's Knocker. I gotta change that. Whoops. But yeah, Zanuck is working on the AI programming, and he's currently programming the heliostat that is on my roof. Okay. Besides uh turning plastic into oil or turning tires into pyrolysis oil, we're also looking for some other avenues of turning waste into useful things. And these are some of the side hustles, right? Like if we're going to be collecting materials, we might as well also, if we're going to be collecting plastic waste and tires, like if we're out doing pickups for that, we might as well also pick up this because it's there. And we can also process these products as well and turn them into useful things. And that's kind of our business model is like you have a waste product, we'll bring it here and we'll do something useful with it. So biochar, um, turning wood products into charcoal through pyrolysis. We can also turn pyrolysis oil into charcoal as well. Interesting. Mattress shredding. So if somebody wants to throw away a mattress, I think we've all been there before, where it's like, what do I do with this mattress? It's really a pain to throw away. We'll come pick it up and we'll turn it into insulation. We'll turn it into something useful, alternative insulation. We'll upcycle it. Um, Tire to fuel, as I touched on before. Box spring houses. So if somebody's throwing away a mattress, they probably also want to get rid of their box spring as well. We'll take that and we'll turn it into alternative housing or a shed or something. And then finally, what I really want to do is composting. There's no money there. It's just one of those other things that we can pick up and turn it into something useful. So thank you so much for watching. I hope you enjoyed this presentation.